Okay, good morning. So here I will go over one of the questions from homework. So this is homework from section 6.1. And we have a function f of x equals square root of x, g of x is equal 9x plus 7. And we have to find the following compositions of f composed with g, g composed with f composed with f, and g composed with g, and state the domain of each. So let me start with A. Let me see. Okay, I will start with A. Okay. So we have f is equal square root of x, g of x is equal 9x plus 7. Okay. In part A, they ask f composed with g. So f composed with g, so this is the same as f of g of x. So we create a composition. So f is outside, so I copy the function f, which is square root of x, and where we used to have an x, we're going to replace x with equation of function g, which will be 9x plus 7. So this is the composition, f composed with g. Now, they ask you to find the domain of that composition, which is f composed with g. So again, domain of f of g of x. So how you find the domain of composition? So first, you need to find the domain always of the inside function. So in our case, the inside function is g of x. So function g of x, again, is 9x plus 7. This is just a straight line. So domain of g of x is all real numbers, which is from negative infinity to infinity, because g of x plus 7 is a straight line. So you can, for x, you can plug in any real number, and you always will be able to evaluate the y value. So when you find the domain of inside function, next, which is second, find the domain of your final composition, which is in our case, it's f composed with g. So f composed with g, it's square root of 9x plus 7. So to find the domain of this function, so you have a square root function. So to find the domain, you have to give the condition that expression under radical, which is 9x plus 7, it's greater or equal to 0. Because to be able to evaluate the radical, we know that under square root, you need to have a 0 or any number greater than 0. So to find the domain of this composition, we have to just solve inequality for x. So we subtract 7 from both sides, and we're getting 9x is greater or equal negative 7, divide each by 9, and we're getting that x is greater than equal negative 7 over 9. So when you have domain of final composition and the domain of inside function, which is all real numbers, the third step will be combine all two together. So third, combine the first and second domain together. So again, we have all real numbers and x greater or equal -7/9. So when you combine all of them together, okay, that's our x's. The first one is all real numbers, which is from -infinity to +infinity. The second condition is x is greater than equal -7/9. So when you combine all of them together, so you're checking where the number line, where two colors overlap. So the final answer will be this. This is our domain, the combination of both. So domain is, and let's see, type an inequality. So they want you to type the inequality, so you're going to put it that way. All the x's such that x is greater or equal -7/9. Because my MATLAB, here for that answer, they want you to type inequality. Okay, so that will be the answer. Okay, so that was part A. Now I will talk about part B. So part B, okay, I should have enough space. Part B of this problem is you have to create a composition G composed with F, which is the same as G of f of x. So what happened, you're going to start with the equation of function G, which is outside function. So we have 9x plus 7. And where you used to have an x, you're going to plug in the equation of function f of x. So function f of x is just square root of x. So we replace the x of function g, because function g is outside. So we replace the x of function g with the equation function f of x, which is square root of x. Okay, so this is our composition. And now what we need to do, we need to find the domain. So the same thing. So to find the domain of G composed with F, which is again just 9 square root of x plus 7. So first, find domain of inside function. So inside functions, it's f of x, inside function, which is f of x equal square root of x. So domain of function f, again, you have square root function, so you have to give the condition that x is greater or equal 0. Okay, so we have that. So that's the first part. Now, second, find the domain of your composition. Of G composed with F. So G composed with F, it's 9 square root of x plus 7. So again, you will have to give the same condition that's square root of x. We know that the expression under square root has to be 0 or greater than 0. So you will still have to give that condition that x is greater or equal 0. And third, you just combine, or you're looking for intersection, combine the two domains. So I'm not going to graph it since both domains are the same, which is x greater equals 0. So the answer will be the domain of G composed with F is just all the x's such that x greater equals 0. And again, it looks like they want you to type inequality for the domain. So that was part B. Part C, they want you to find F composed with F. Part C. you have to find f composed with f, which means f of x. So what happened, inside of we're used to have x of function f, you're going to plug in the equation of function f of x. So f of x, again, it's square root of x So f of x, again, is just square root of x. Okay, so that's f of x. So what we're going to do, function f, which is square root of x, right? And where I used to have an x, I'm plugging in square root of x. Okay, so this is our f composed with f. And now we have to find the domain. So domain of f composed with f. So the same thing, first domain of inside function, which is f of x. So f of x is square root of x, so we know that the domain is x greater equals 0. And here, I think they will allow you to leave this expression that way, because let me just show you guys that square root function, so you have square root of x right here, that inside square root of x, right? And that square root, which is outside, if you want to change to exponential, so this is the same as that square root of x, it's going to bring to the power of 1/2. And now, again, that square root of x right here, I'm going to rewrite as x to the power of 1/2. And then I have that power 1/2 outside. So that will be the same as x to the power of 1/4. So you want to keep it that way. Radical of 4x with index 4 of x. So I can let me know, but I'm pretty sure that that's how you should enter your final solution, that f composed with f. Okay, so f composed with f, we just put it that way, is radical of index 4 of x. So that radical behaves like square root of x. Okay, so first what we're going to do, we're going to find the domain of inside function, which is f of x, which is x greater than equals 0. Second, domain of your final composition, index of 4 of x. So the same thing, domain of this function is also x greater equals 0. So third, when you combine first and second domain, so we're getting the same thing. We're combining those two domains together, so you will get domain of f composed with f is all the x's such that x is greater equals 0, because we combined those two together. And the last part of this homework was part D. Let me try it to squeeze right here. So part D, they asking, try to separate that way. So that would be part D. Okay, so we're working on D. So G composed with G, so this is G of x. So this is a G of x, function G of x has equation 9x plus 7. Okay, so what I'm going to do, I'm going to start with equation of function G, which is 9, originally was x, plus 7, and where we used to have x, we plug in the equation of inside function, which is 9x plus 7. Don't forget, put that in parentheses, because we will need to distribute that 9. So let's simplify this, and that will become that G composed with G, it's equal 9 times 9x, which is 81x, and 9 times 7, that will give us 63, plus 7, which is on the side right here, plus 7, and that will give us 81x plus 70. So this is G composed with G. And now we need to find the domain. So domain of G composed with G. So G. So first, find the domain of inside function. So function G, look what happened. Function G, it's 9x plus 7. So this is linear function. So domain of linear functions always are real numbers, which is from negative infinity to positive infinity. So domain of function G is from negative infinity to positive infinity. Second, you have to find the domain of the composition. So our composition function, which is right here, 81x plus 7, it's also a linear function. So domain here, it's going to be also from negative infinity to positive infinity. So third, the domain, the final answer for domain is, and you guys will select all real numbers. So the answer for this one will be is all real numbers, which you will select that answer B. Okay, so hopefully that will help. I squeezed that a little bit on one piece of paper, but again, hopefully you will be able to figure out. So thank you, Sarah, for sending that question. Also, we'll post that on the discussion. So maybe students who struggle with composition can benefit from that recording. So thank you so much. Okay.